Thank you, guys. This is a continuation of what we have learned from the previous lesson, DC theory. Remember, we were busy with the combination of series and the parallel circuit, and we only managed to calculate the total resistance. So then remember I said you can continue with the rest of the questions so that you are able to pick up your strengths and your weaknesses on these DC circuits. Now, a circuit like this, when you look at it, it's a bit complicated, but we have to break it down to simpler terms. Now, what we are going to do now, we are going to analyze the circuit first before we can even do the calculations. Then we reduce the circuit into simple terms, meaning we have to reduce what? The number of resistors, particularly the parallel resistors. Now, can we start by calculating the total resistance of the circuit? Remember, I said be careful or consider the mark allocation, because it tells you how much you have to do, how much you have to come up with the solution, how long do you have to go throughout this question so that you can get these 5 marks. So please, in most of the times, consider the mark allocation. Now, let me analyze this circuit whilst you are watching the analysis of the circuit so that you can come up with the solution. This is the positive terminal of the battery. Now, the current, it flows from positive to negative, meaning this will be the direction of the current. Then it comes back to the negative terminal. Remember, it's a direct current. It doesn't change the direction. It's a direct current, directly from the positive terminal to the negative terminal. Now, from this positive terminal up to this junction, we call this junction. That is the term that we use in electronics, or a point where the current will divide or where the current will split. Now, when the current split here, the other one, it will take this direction, the other one, it will take this direction. Now, the one that's taking this direction, it will flow across R3. I believe everyone is able to see R3, that is 18 ohm. And there's another junction here, whereby the current will split again. The other current will take this direction, and this is the current that will pass across what? R5. This is the current that will flow across 5 ohm. R5, or this one is R4, and this is the current that will flow across R6, of which is 20 ohm. Remember, the current was divided here, but it will meet here. This is the point of combination. That's why you will find the total current for the 3 resistors. Remember, we said when the resistors are connected in parallel, application of Kirchhoff's current law, the sum of currents equals to the total current for those resistors where the current has passed through. So now that simply means now R4, R5, and R6, they are connected in parallel simply because of the 2 junctions, right? But now the combination of the 2, it is connected in series with R3. Why do we say it is connected in series? Simply because of there is no junction between R3 and a single resistor, which will be replaced, which has replaced the 3 resistors. Remember, immediately when you get the answer here, you will be having 1 resistor. I believe that we have analyzed it properly. Now I want us to analyze this section, the connection of R1 and R2. Now the question is there a junction between R1 and R2? The answer is no, there's no junction. So if there is no junction, it simply means now R1 and R2, they are connected in series. So that simply means now here we are sorted. We don't have a parallel branch. So what we are going to do now, I always advise my students to start with the complicated part of the circuit so that you are able to come up with a circuit that is in the most simplest form. Right. Now, the current was divided here and then it will meet here again. So in other words, the value of the current that is entering this point, it should be the same as this one. Now, remember it's a junction. That simply means now this part, it is parallel to this part. Meaning the answer that you are going to get for this section, it will be parallel to the answer that you are going to get for the two resistors. I hope it makes sense, right? Now, and that's where you are going to get the total resistance. Now, can we start with the most complicated part? Remember, I said the parallel circuit. That's where we have a lot of complications because we have to break it down and make it one single resistor that is equivalent to the three resistors. Now, which formula do we use to calculate the parallel resistance? Now, it's 1 over R. 1 over R4 plus 1 over R5 plus 1 over R6. Now we have identified this part as the first parallel section. Now we are going to label it as RP1. Some they use their own way of labeling the parallel resistors and the series resistors. So let's do the substitution. It's 1 over 4 plus 1 over 5 plus 1 over 20 because R6 is 20 ohm. Now let's use our brains. Those who have calculators, they will use their calculators. Now because of I don't have a calculator, I'm going to use my brain. Okay? So it's 20, that is your denominator. 4 into 20 goes 5 times 1 is 5. 5 into 20 goes 4 times 1 is 4 plus 20 into 20 which is 1 times 1, that's 1. So now you have 10 over 20. But remember, we are not looking for 1 over RP1, we are looking for RP1. So that simply means now we have to do the inverse of this. We say RP1 over 1 is the same as 20 over 10. That will give you the answer as 2 ohm resistor. Now, it simply means the combination of the three resistors is 2 ohms. Now, the three resistors are replaced by one resistor, and the value of that resistor is how much? It is 2 ohm. Now, I'm going to draw a simplified circuit after you have done these calculations so that we can see from this part where do we have to go. This is the resistor that has replaced the three resistors of which is RP1, 2 ohm. Now, following the direction of the current, people, please remember to follow the direction of the current. Don't go to the other section, then you jump onto the other section because that will confuse Even you confuse yourself at the very same time. So we are still on this line, we are still on this conductor. Now we are going to say the two resistors, they are connected in series. Why? Because there is no junction between them. Now allow me to say this is, remember we said R1 and R2, they are connected in series as well. So I will say the first series connection, it is R1 and R2. Let's substitute the values thereof. It's 10 plus 20, of which is 30 ohm. Then the second series connection that we have identified from the simplified circuit. Good people, it helps to draw a circuit diagram. As a problem solver, you need to know where you have started and where you have ended. So the circuit diagram, it helps you to know which direction you're supposed to take based on the sketches there. Then the second series connection that we have identified, we said is R3 and RP1. Don't forget, RP1 is the combination of the three resistors. Substitution of 18 plus 2, that gives you 20 ohms. Now, can we agree that we only have two resistors in this circuit, of which is RS1 and RS2? Now, I prefer to draw the circuit diagram again that represents the two resistors, RS1 and RS2. This is your RS2 and this is your RS1. The value of RS1 is 30 ohm. The value of RS2 is 20 ohm. We still have junctions. This is your supply voltage. Right. Now, when you look at the two resistors, remember we said if you have the junctions between the resistor at the beginning and at the last part of that circuit, that simply means those resistors are connected in parallel. So when you look at this circuit, there's a junction. In other words, the current will split here, but it will meet again here. You can always make use of arrows so that you are able to keep the direction of the current in the right order or in the right manner. The supply voltage is still 90 volt. Now, RS2 and RS1, they are connected in parallel. Now, in simple terms, that will be the total resistance of our circuit, because those are the only two resistors that we are remaining with. So RT will be RS1. This is the formula that we use to calculate the parallel resistors in a series parallel circuit, divided by RS1 plus RS2. So it's 20 times 30 divided by 20 plus 30. The answer is 12 ohms. So the total resistance of this circuit is 12 ohms. Now, I'm going to draw the last circuit now, the simplified one, whereby you have one resistor, only one resistor. That is your total resistance of the circuit. It's 12 ohms. Together with the supply voltage. So can you say that all the resistors from this circuit, they are being replaced by what? By a 1 resistor, of which is 12 ohms. That is the total resistance of the circuit. I hope you are enjoying it. I hope that it also makes sense and it also gives you some clarities if maybe you were confused by these circuits, or if maybe you were confused by a number of resistors in this circuit. Still have the voltage of 90 volts. Right. Now, we are going to concentrate on the second question, whereby they say we should calculate the total current of the circuit. Again, consider the mark allocation. It's 2 marks. So that simply means now you don't have to sweat. You don't have to sweat. It might probably be 1 or 2 steps to get the total current of the circuit. You ask yourself, which formula am I going to use to find the total current of the circuit? Ohm's law formula, which says IT, we are on 1.2, IT is equals to VT over RT. So it's going, VT is 90, the total resistance of the circuit is 12. Those who have calculators, please punch your calculators, and those who were born before the calculators arrived, we are going to use our brains. 90 over 12, it gives you 7.5 amps. Happy? Yes, because that is an application of Ohm's law. Right. Now, it's 2 marks. Hence I said you don't have to sweat. It's only the formula substitution and the final answer. So, mark allocation should be considered at all the times. Now, the third question, it says calculate the voltage drop across R1. The voltage drop across R1. Now, you go back to your original circuit. You look at the value of R1. R1 is 10 ohms. Then you ask yourself a question, which formula am I going to use to calculate the voltage drop? Now, let's work it out. Let's work it out. Let's try to find the voltage drop. I believe that you guys have the original circuit diagram. So we are going to use the simplified circuits. I still need the questions, so I'm not going to raise them. Right. For you to calculate the voltage drop, you need the current and the value of that resistor. In other words, this is the formula. V equals to I times R. So because it is the voltage drop across R1, we are going to write it as VR1. Now the question is, do we have the current across R1? No, we don't have the current across R1. The only current that we have for now is the total current of the circuit. So basically, we have to find the current across R1. And I want us to agree that the current across R1 is the same current across R2, because the 2 resistors are connected in series. So if resistors are connected in series, the current thereof is the same. So in other words, we have to consider the sum of the 2. In other words, we have to consider what in this circuit diagram, RS1, because the sum of the 2 is 30 ohm. And remember that this 30 and 20, they are connected in parallel. What did we say about the resistors when they are connected in parallel? We said the voltage is the same. So in other words, the voltage across RS1 and the voltage across RS2 is the same. Then fortunate enough, we do have that voltage of which is 90 volts. So we are going to use 90 volts to find the current across RS1. Then as soon as we have the current across RS1, it simply means now we have the current across R1 and RR2. Allow me to find the current across RS1. I will say it's IS1. That will be VT over RS1. That is 90 over 30. The answer is 3 amps. So that is the current across RS1. And remember, if it's 3 amps, it simply means now it's 3 amps here. There is no junction. The current doesn't split. Here it's also what? 3 amps. Now we are happy because we do have what? The current across R1 and R2. We can find the voltage drop. So we go back to the formula to calculate the voltage drop. We say this is IS1 multiplied by what? By R1. The value of IS1 is 3. The value of R1 is 10. Then the answer is 30 volts. So the voltage drop across R1, VR1 is equals to 30 volts. Now, some people, they already have that thing in their mind that the sum of the voltage drops across R1 and R2 should give us what? 90 volts. Remember that 90 volts is the one that we've used to find the value of IS1. So in other words, when you calculate the voltage drop across R2, you are going to use the very same current. You are going to say 3 multiplied by what? By 20. It's not part of the questions, but for the sake of understanding and simplicity and perfecting our calculations or our understanding, we will say VR2 is equals to IS1 multiplied by R2. So that will be 3 times 20 because we said the current is the same. The answer is 60 volts. Now, what comes back into your mind is the Kirchhoff's voltage law, whereby it says the sum of the voltage drops in a closed circuit is equals to the total applied voltage. In other words, we are going to say VR1 plus VR2 is equals to VT. So it's 30 plus 60, of which is VT. Then it simply means now our calculations, they are correct because we have obtained what? 90 volts. So can you see that these laws, the Kirchhoff's laws, they help us to prove the answers as to whether they are correct or not correct. So we are done with the voltage drop across R1. The current across R2. It says 2 marks. So it simply means now you don't have to solve it again. What we have to do, you just have to apply the current that you have already calculated. Probably you even have the answer for 1.4. Remember we said the current is the same for R1 and R2. So if R1 is 3 amps, it simply means now R2 is also 3 amps. So you have already answered that question in the previous steps. So IR2 is equals to 3 amps. You are sorted. All right. Now let's move on to 1.5. It says the voltage across R6. The voltage across R6. Now R6, it's one of those 3 parallel resistors. Now, you don't have the current across the combination of the 3 parallel resistors, but you can find it. I will say this is my IS2 and this is my IS1. 1. So remember, IS1 is equals to 3 amps. Application of Kirchhoff's current law, IS1 plus IS2 is equals to IT. We are looking for IS2. Make IS2 the subject of the formula. That will be IT minus IS1. So it's 7.5 minus 3. The answer is 4.5. Then we are going to use this 4.5 to calculate the voltage across the parallel combination. We are almost done. We are almost done. I believe you are still happy with the workout. Then you will say VP1, because the combination of the three resistors is RP1. VP1 is IS2 multiplied by RP1, because the voltage for the three resistors is the same. So we are going to say 4.5 multiplied by what? By 2. That is 9 volts. So since when the three resistors, they share the same voltage, it simply means now the voltage across R6 is equals to what? 9 volts. The voltage across R4, R5, and R6 is the same. Both, all of them, they share what? 9 volts. Right. Now, the last question, it says the current across R4. The current across R4, we are going to use the very same voltage because we said the voltage across R4, 5, and 6 is 9 volts. We are going to say IR4 is equals to VP1, or you can say VR6 VP1 over R4. You do have the value of VP1, that is 9. The value of R4, if I still remember well, it's supposed to be 4. Then the answer it will be 9 over 4. It's 2.25. 2.25. amps. So that is the current across R4. Now, after you have worked out all the calculations, or you have solved the circuit, you need to go back and see as to whether when you add those currents, do they give you the total current of the circuit, the total voltage of the circuit. And what are you using in that case? You are using the Kirchhoff's laws. Now, that simply means now the current across R3, it should be the sum of the three currents across R4, R5, and R6. I believe all of us, we are on the same page. Whenever you come across a question on a DC circuit whereby there's a combination of the series and the parallel circuit, please make sure that firstly you analyze the circuit. In summary, you analyze the circuit, you look at the flow of current, then from there you look at the complicated part of the circuit, of which you start by reducing the parallel resistors. Then you are forming a series circuit so that your circuit is in simplest form. And then don't forget that you always have to apply the Kirchhoff's laws. I'm talking about the Kirchhoff's current law and the Kirchhoff's voltage law to prove your answers. I wish you all the best as you prepare for the exams, as you will be doing the revisions with your classmates, with your lecturers, considering all the necessary principles that we follow to come up with the correct solutions when we solve the DC circuits. I thank you once again.